This is our solar-powered plaza proposal by Andrew Chen, Laura Karadang, Rio Kono, Rishi Tandon, and Ankit Shah. We would like to propose to you our design of a solar-powered plaza in front of Pupil Hall. This plaza features several amenities such as exercise bikes, a TV, an internet server, and massage chairs, all of which would be powered by harvested solar energy. We believe that this plaza would be a useful resource for both students and the university as a whole by providing a space to interact while implementing sustainable technology. Our solar powered plaza will benefit the university as well as student life at the university. There is already free green space in Pupil Plaza that is not currently being utilized, and building a solar plaza will be a great way to use the space.
So to go into detail about the benefits that this solar-powered plaza could have on the university, for one, there's an abundance of free green space that the university could use to promote student interaction. Obviously, fossil fuels are harmful to the environment, and we want to find different ways to provide energy for our daily needs. PV cell prices are dropping, which makes it pretty useful in terms of harvesting solar energy. This design that we've proposed to you is cost efficient, and it would serve to raise awareness for various earth and environmental programs that the university hosts. The plaza would also encourage healthy living and exercise in terms of spending time outdoors, interacting and eating with other students and faculty outdoors. Also, the solar PV system could be used to power emergency appliances during any natural disasters that might occur. And finally, just relaxing and spending time outdoors is a natural stress buster. It could promote stress relief. So that's final. In addition, there are many student-led benefits such as internet access, charging stations, night lamps, television, vending machine that serves drinks and food, relaxing area, and exercise bikes that could produce additional electricity.
Above we see the design of the proposed plaza. The structure is inspired by the sunflower, a natural phenomenon known for training to receive maximum exposure to sunlight throughout the day. Our design not only implements the beauty of the sunflower, but also serves as a structural basis for supporting a solar PV system and many useful amenities. Arrays of solar panels are located along the top of the structure to harvest energy for subsequent use. The materials used will also be designed to withstand temperatures to which they are exposed, and sunlight and UV rays.
The solar panels are structured by First Solar, and we're using FS390 solar panels. They produce roughly 90 watts per solar panel. We are connecting the solar panels to the main grid so that the solar energy can be harnessed by the university itself when the plaza itself is not used. According to the National Renewable Energy Laboratory, a 2.3 kilowatt PV system will produce 249 kilowatt hours, 268 kilowatt hours, 272 kilowatt hours, 248 kilowatt hours, and 236 kilowatt hours for the months of March, April, May, September, and October. We're going to use the data from October because it is the lowest, and we're doing this for conservatism. This is assuming an area tilt of 40.8 degrees, which is roughly the latitude of New York City, and an area azimuth of 180 degrees. These months are going to be the ones that we are going to actually use the plaza. Now the batteries that we are using are LiF, lithium iron phosphate, and we're using them because of their high energy density, longevity, and inexpensiveness. From this online article, we found how to size a battery bank. We estimated that we want to have at least 2 days of energy backup, so we're multiplying the energy required per day by a factor of 4, where 2 days divided by 0.5, which is a discharge depth that we want. And that will give us roughly 30 kilowatt hours. And these are our calculations. Specifically, if you look at the top, we needed roughly 26 solar panels, but factoring the fact that 15% of the solar insolation is lost because of shade, we divided 26 by 1 divided by 1 minus 0.5, and we got 30 solar panels. Now each solar panel takes up 0.72 square meters, and multiplying that by 35 gives us 25.2 square meters total.
The solar server will be functional 24 hours a day and will display useful information regarding the power used, generated, and stored in batteries. The information can be accessed through the website and also displayed on the television. This will be beneficial to the students and university as it will raise awareness and encourage students to be more energy efficient.
The placement of the solar panels would be extremely crucial. They will first be at approximately 40-degree tilt to receive maximum sunlight. We must also account for shadows from nearby buildings. During the fall, the plaza will start receiving light at approximately 7:30 a.m. and receive full light at 8:30 a.m. At approximately 2:30 p.m., shade will start to cover the plaza, and at 3:30 p.m., the plaza will receive normal sunlight. This accounts to a total of 7 hours of sunlight per day in the fall.
In the spring, the sun rises a little later, 30 minutes later, so the system will start to receive sunlight at 8 a.m. and will receive full sunlight at 9 a.m. At approximately 3 p.m., the shade from Havemeyer will start covering the plaza, and at 4 p.m. there will be no more additional light supplied to the system. So just like the fall, the solar panels will receive about 7 hours of light a day.
For our amenities, we decided to have exercise bikes, massage chairs, a television, tables, outlets, and lighting, and a vending machine. We chose the exercise bike because we think that these will promote an active lifestyle to the students and faculty, and also provide additional power to the PV system. The massage chairs can be used to relieve stress during the day, and the television can be used to display daily announcements and other useful information about the solar server, the weather forecast, dining hall hours, and more. The tables, outlets, and lighting are important because then students can work around in the plaza and be able to charge their electronic devices, and the energy efficient lighting will output a total of 8,000 lumens, and it will allow students to work late into the night. The vending machine can provide food and drink for students who need to stay hydrated, and it'll generate a solid source of revenue for the school. Here's a table of our amenities, and it lists the price, the power rating, the electric potential, the current, the number of devices, number of hours used, and the energy consumed per day in kilowatt hours. So we were able to calculate the total energy consumed per day, which is 7.397 kilowatt hours. In order to calculate this, we use the information in the table that we found, and we use the equation energy consumption equals power times time times devices used, and we use the kilowatt conversion factor, so all of our answers would be in kilowatt hours. And here are the calculations.
These amenities will provide a community for students to study and socialize. Thus, adding a solar energy powered space for students to interact would greatly benefit the energy and vitality of Pupin Plaza. By constructing this monument, Columbia University will illustrate that its belief and commitment in sustainability. Furthermore, because of its creative design, Columbia will demonstrate that its engineers are not typical and uninspired, but rather creative, knowledgeable, and dynamic. Thus, the solar-powered plaza should be constructed because it will greatly improve student life and vitality. Thank you for watching, and here are our sources.